You're listening to Inside Air, a behind-the-wire view of the Royal Air Force, its people, technology and operations.
Hi, I'm Flight Lieutenant Chris Sully and welcome to the latest RAF Inside Air podcast. In this episode, we're at MOD Boscombe Down in Wiltshire to explore the engineering science behind the world of test flying.
But that is across aviation, so be it F-35 Typhoon, the I-Star Force up at Waddington, but also the helicopters of all three services down here. Test parachuting is a big thing at the moment with the C-130 going out, and we're moving progressively into uncrewed testing as well, and developing that. So there's a lot of activity going on.
As you say, we work very closely with Airbus in Seville, but also with the Rapid Capabilities Office, we're working on the successor to the Tutor training aircraft, and the challenge was to have a net zero elementary flying trainer. On that journey, the Air Force has given money to industrial contractors to try and design that tutor replacement. We've got test pilots and flight test engineers that are going to work with them over the next 2 years.
It is an amazing job. Okay, so and the breadth of aviation, technology and people that we get to see operating within that enterprise is huge. So it's a very liberating job.
As usual, we'll also reheat a few stories which might have slipped under your radar, and we'll be finding out who's under the hat this week with Ben.
Hardest part of your job? Well, I'm 44 now. I can still keep up with the mid-20-year-olds, but it certainly is getting harder and certainly taking longer with recovery.
If you've ever travelled down the A303 en route to the West Country, just a few miles to the east of Stonehenge on the Salisbury Plain training area, you'll find MOD Boscombe Down. It's home to tri-service military aircraft test and evaluation. Put simply, their job is to ensure that every piece of flying kit used in the British military, from aircraft, both crewed and remotely operated, to parachutes for people and equipment, from software to systems and procedures, is fit for purpose and ready for use globally. In this edition, we'll find out whether there's still a place for a pilot to be physically present when so much can be done with computer simulation, and find out how it all comes together with the various team members. Back in July, Squadron Leader Peter Lisney talked with then Chief Test Pilot Group Captain Steve Berry and OC 206 Squadron Wing Commander A.D. Wolven, both of whom have now moved on to new roles within the RAF.
So I'm at MOD Boscombe Down, Wiltshire, home of military aircraft test and evaluation, and I'm with Group Captain Steve Berry and Wing Commander A.D. Wolven. It's good to have you on Inside Air.
Hello, Peter.
Hello, thanks so much.
To start with, we're going to be talking about test pilots and the engineering that goes behind being a test pilot. Could you just start by telling us what your role is? And if we start with you, Group Captain.
So I'm the Chief Test Pilot from the Air and Space Warfare Centre, and I'm charged with being in charge of the enterprise that does all test and evaluation for MOD aircraft. So it's not just RAF, we also do Royal Naval and Army helicopters as well. And below me sit a number of squadrons that conduct that for me, of which Wing Commander Wolven here is one of the commanding officers.
That's right. So I'm the squadron commander of 206 Squadron. We're based at RAF Bryce Norton, and we do all of the testing for the Air Mobility Force. So all the platforms at Bryce, as well as the Envoy now at Northolt. And we've also covered off the training aircraft around the UK and some broader work, such as working with the parachuting test team.
Now, you called me up and said something along the lines of, I'd like to be on Inside Air. And I said, what do you do? And you said, you're Chief Test Pilot of the Royal Air Force. And I thought, now it's got to be an interesting topic.
Yeah, so it is an amazing job. Okay, so and the breadth of aviation, technology and people that we get to see operating within that enterprise is huge. So it's a very liberating job, and it was something I was really keen to tell the world about, if I'm honest, and particularly to get, for example, AD here on to talk about some of the stuff we've been doing for the Air Mobility Force. But that is across aviation, so be it F-35 Typhoon, the I-Star Force up at Waddington, but also the helicopters of all three services down here. test parachuting is a big thing at the moment with the C-130 going out, and we're moving progressively into uncrewed testing as well, and developing that. So there's a lot of activity going on, and an awful lot to talk about, to be honest. I mean, I'm sure we could fill hours and hours and hours talking about the sheer scale of what's going on. But it is, I have to say as the top of the organisation, I will say anyway, it is a great train set. It really is that straightforward. It's boys' own stuff some of the time. It really is.
Okay, do you know what? We'll go to that because if you wind the clock back to the 1950s, test pilots then, some of them were household names. You've got people like Eric Winkle-Brown that I'm sure many people have read his memoir. I'm going to throw the big question to kick us off now. So in this synthetic world we live in, why do we still need you?
Yeah, that is a great question. So things have substantially changed since the post-war period, where there was it was very tricky to predict either the performance or the flight characteristics of a particular aircraft. So it was back to the strap it on and see what happened, and the accident rate reflects that. In this modern era, we are able to increasingly better model and better simulate how those platforms as air systems might work, be it aerodynamically, performance, handling characteristics, also the sensor performance as well. But none of that's perfect, and I would love to say that every system we got, the Mark 1 version, worked perfectly every time, and sadly that's not the case, and that's not a spear against anyone. These things are increasingly complex. They are harder and harder and harder to make perfect, and because they are, I suppose, small volume, when you look at your iPad and think, by the time that pitches up or my iPhone pitches up, that's it's almost perfect. It's like some bugs. Okay, but the volume of testing they've done prior to it getting into your hands as a consumer is huge, vast compared to the amount they can actually do on an aircraft. So nothing arrives perfectly every time, and as a result, there is still a requirement and activity to actually put things through its evaluate it, test it, and assess it prior to entering service. So there's still something there. Now, has it shifted? Yes, it has shifted from the pure, can it turn around a corner without falling out of the sky, to how effective can it be as a military platform now, so lethal for a combat air system, able to detect for an I-star sort of aircraft, or able to deliver the right military capability, such as AD's platforms on the air mobility side. But there's still a lot of work to do, but the shift in the techniques required has happened, but it's still a requirement to do it, and we can't do it perfectly through digital modelling and simulation. Sadly, that's not the case. It is quite an expensive business to go down that route.
Well, I'm sure the engineering is not as agile as it was 70 years ago. So if the airspeed indicator was in the wrong place, you move it, put a phone call in and, can you just move that to the top left-hand corner of the panel? When you raise issues, what is is it a 10-year consequence to get things changed? So
to avoid exactly that, and you are correct, it does take the design changes to percolate through from something that's programmed, typically software programmed nowadays, to be on the front line. It does take a while. So to avoid that, to absolutely make sure we avoid that, we try to lean as far left as we can in the development process and go and work with industry, and we've got very good linkages with them. On the A400, working with Airbus out in Seville, the Typhoon. My guys and girls from 41 Squadron will go to BA Systems routinely. Same with F-35. Same with all the platforms and systems, so that we can try and make sure we iron out those problems early. But if we do find problems, we know the right people to go to, we know our mechanisms, and we're in a combined test team environment to feed it back as quickly as we can to try and iterate those problems out as rapidly as possible. So you are right, the design process is long. The idea is we try and minimise the impact of that by leaning as far left as we can.
Yeah, and we've, as you say, we work very closely with Airbus in Seville, but also with the Rapid Capabilities Office, we're working on the successor to the Tutor training aircraft, and the challenge was to have a net zero elementary flying trainer. On that journey, the Air Force has given money to industrial contractors to try and design that tutor replacement. We've got test pilots and flight test engineers that are going to work with them over the next 2 years to really be right at the start. And as you talk about, I'd like the SB indicator to be there or there or there. We've really got our hands almost on the drawing board on that one.
If we talk about 6th gen aircraft, Tempest, are you involved in the design elements for that?
So again, on the combined test team view, if you like, that I just described, the demonstrator aircraft, which is supposed to be flying in a few years' time, we have a test pilot from 41 Squadron, the Typhoon Test Squadron, who's embedded within that sort of that combined test team, and we're about a year into looking at how, for example, the flight control system is going to be tuned, doing that through a synthetic rig that we're working through a bunch of design philosophies and refinements so we can tune the flight control system on the ground. So that's already happening. As it happens, my replacement, I'm due to replace fairly soon, is coming from the FCAS main programme. And one of the visions we've got to look at is how we join up with the other partner nations and their industrial components to combine not just a combined testing UK, but combined testing broader potentially. So that's definitely something we've already started to look at. And it's definitely something we've got a vision on for the future to be involved, whether we will be involved with that.
Because you're a test and evaluation unit, you're right there at the sharp end of this development. Yeah,
and it's fascinating, and it's definitely, and I would highlight as well, we are deliberately flowing not just test pilots, but the test professionals, which consists of test pilots, but also the flight test engineers who we've got qualified, and other people who've been involved in the broader system, and we're deliberately trying to flow those through into the Future Combat Air Programme to help lean in and shape that early engagement. And I think that's probably definitely one takeaway I would like to put out there, which is when I entered flight test, as it were, became flight test professional a while ago now, the thing I realised most is that it's the biggest team game you'll be in. And yes, all military aviation is a team game. People are there supporting components to try and get an air system into the air with the appropriate crew on board to deliver the effect. But within flight test, the breadth of that team is so much broader, because you've got someone from industry, you've got someone from the front line, you've got someone who's got the money, you've got someone who's doing the program management, you've got some very deep technical specialists who probably don't understand your role well enough and you need to help shape that. And within that very, very, very broad team, sometimes you need to be leader. You need to shape it where it's going. Sometimes you need to be a follower. You just do as you're told, because the person who might know most about something you're going to go and conduct in the air could be some 22-year-old technician, could be a 25-year-old scientist, it could be a 60-year-old industrial guru who knows exactly how to make these things work. So being able to flex and flow within that team is, I think, one of the defining features of the test and evaluation environment. It is a big team game. Do you agree with that?
Yeah, no, exactly. And a lot of that skill, and some of the skills that we're trying to ask our candidates that we're selecting now for the next Empire Test Pilot School is about that communication, isn't it, and making the most out of the individuals in the team. And I've worked with some incredible teams in test and evaluation, and on the flip side, I've worked in 2 or 3 person teams where it's a real struggle for us to get over the line, and quite a sort of interesting viewpoint on teamwork.
So, talking about the team then, as Officer Commanding 206 Squadron, based at RAF Bryce Norton, fixed wing test and evaluation, you are not a pilot, but you run the squadron.
Yeah, that's right. I trained as a flight test engineer on exchange with the French equivalent of Empire Test Pilot School over 10 years now, and I've done tours where I've done test and evaluation on large aircraft, and then done mainstream engineering roles such as Sengo on A400M.
Senior engineering officer.
Yeah, that's right. Yeah. And then I was selected to be the squadron boss boss of 206 Squadron, and so very unusually a non-traditional aircrew running a flying squadron, which I've done for the last 2 years, and it's been a great privilege, really. Hopefully, bringing some of that flying and test knowledge that I've had over my last tours, and with some of that kind of engineering thought and practice as well.
So, from when you joined the Air Force through to the role you have now, you work very closely with aircrew. How'd you get on?
Yeah, I mean, they occasionally break the aircraft, which is a bit of a shame, isn't it? But no, generally really well. I think that the role that I've really enjoyed, sort of almost being an aircrew facing flight test engineer, is that understanding the mission or the thing we're trying to get this aircraft to do, and really trying to unpick the thought process of the aircrew. So that's the pilots, or could be our load masters in the cargo hold of the aircraft, to really understand what they're trying to do and why. And you're finding that difficult. Well, why are you finding it difficult to use the aircraft in that fashion? Is it the displays that are making it hard for you, for example? Is it the number of button presses? Is it that you're just trying to use a sort of traditional legacy aircraft approach, when actually when you start with a bit of a fresh canvas? So whilst I don't always have the sort of aircrew knowledge of how it's done on the C-130J, I hope I can be there with those challenging questions and ask why 5 times. So hopefully it finds the whole trial team's thinking.
What does it mean for your junior technicians, the AS1s, AS2s that are on your squadron, and junior NCOs, to be part of this environment? Tell me the environment on being on your squadron.
Yeah, so I mean, there's the different testing and evaluation squadrons. 41, for example, which does the Typhoon, have their own technicians. We, in essence, don't own any of our own aircraft. We borrow them from the Frontline. So I don't have any of my own.
Give them back broken.
Yeah, occasionally. It's harsh. But I do have Trade Group 1, so aircraft technicians that work on my squadron and do that kind of interface between, we want to drop this boat, for argument's sake, out there, A4M. What roll fit do we need in the back of the aircraft with the right cables and parachute attachments to make that happen? And then work with the frontline engineers to hand over all of that engineering kind of prep work they need to do in order to allow the A400M to do that new role, such as high altitude parachuting or boat airdrop, for example.
So, building on that example then, from the pilot's perspective, there's an impact on perhaps the handling of the aircraft as that payload leaves the ramp.
Yeah, so I'm not an air mobility man, so I can't comment directly. But actually, I went to watch that trial down the back, because for me, for something like an air mobility platform, it is a new view, if you like, for me as a combat airman, is seeing what needs to happen in the front of the aircraft to manoeuvre it and configure it in a way that's there ready to drop the stores, and then seeing the hive of activity that happens down the back end of an A400, and then the linkage between the two. That's normal business with the frontline folk. To sit operating in a test environment where you have to have everything on, not just within the parameters you've been given, exactly the parameter of the test point you need to achieve. And it comes back to my point about who's steering the ship at that point. The pilots are doing the best they can, the test aircrew at the front are doing their best they can to get to exactly that right point. And there's a decision about, are we in the parameters for the test point that we've been told to go and hit? So do we drop, don't we drop? Amazing set of teamwork skill sets sit within that. And certainly, watching the view out the back as a couple of maritime boat payloads go over and the parachute snap open, and then video everything to make sure we collect the data for it. It's a fascinating way to see that particular team go about their business. We're now 18 months into the C-130J replacement program, still with about another year or so worth of work to do. So that the team have been busy doing that for a long time now. And it's not just our team; we have support civilians as well who help out from Kinetic, and the totality of that, is quite amazing.
So the capability that the Hercules provided the UK Armed Forces, which has now retired.
Yeah, sadly, yeah.
The replacement is the Atlas, the A400M Atlas, and so you have been heavily involved in preparing that aircraft for capability.
Yeah, I mean, literally at the point that it was announced that the C-130J would go out of service, that kind of accelerated all of those, filling those capability gaps that we had on the A400M. So high altitude parachuting was the first one we did with several US-based trials. That's handed over to Frontline now, and they're just growing their crews. We've done what's called the maritime boat airdrop as well, and that'll be handed over to Frontline probably start of next year, and our main focus is to get low-level parachuting cleared, which is what the parachute regiment, the 16th Air Assault Brigade, uses as one of their modes for getting into battle. So, I've got roughly 40 test professionals, and probably 2/3 of them are at least some of the time spent on doing A400M work. And I guess in parallel to that, we also did the C-17 high altitude parachuting trials. So as a bit of an insurance policy for the Royal Air Force, not only can the A400M do high altitude parachuting, but the C-17 can as well. And it was my C-17 test crews that did that trial, and then, as equally importantly, handed that over to the front line, and not just the big kind of press release, this is the capability, but all those small little engineering or logistical snags that often hold you back. My team tries to fix all those at the same time.
If there's been any criticism levelled about Hercules going, is not having a replacement that can do everything that Hercules has done. Why would we not be ready the day that Hercules goes out of retirement, or is that just a bit too political?
No, I'll take that on. Well, first of all, I used to be the senior engineer officer for A400M, so certainly its availability has held it back. So I'll take the hit that all those problems are probably caused by me back in the day.
That's a confession.
That's a confession. Yeah. And secondly, I think we had the C-130J in service that was doing all those roles. There wasn't a real, whilst we knew that those capabilities were going to be needed in the future, the C-130J was going to stay in service until I think the 2030. So there wasn't a real impetus. Whereas almost what's driven us to get the A400M in the place it is now is that C-130J going out of service. So no, we've done an awful lot in the last 18 months, 2 years. That low-level parachuting for 16 Air Assault Brigade, I think, was on the plan for 2028. So we've dragged that forward roughly 5 years. So whilst there's some teething problems, there's some success there too.
And I guess if you look at Typhoon, when Typhoon came online, it wasn't a swing roll aircraft.
No, exactly. So here's some rubbish banter then. So when the GR4 was going out of service, we had something called Project Centurion, which was to get the Typhoon to that true swing roll capability. And of course, it was driven very similarly by an out of service date, which was fast approaching. And so I recognised, I was the squadron commander of the Typhoon at the time, and I recognised everything that AD is going through right now with that pressure and mounting pressure on the people, and that whole breadth of the team again, trying to get into service, and we managed to do it. I mean, it was, was it perfect? No, it was not. Was it good enough? Yes, it was. That was called Project Centurion. Okay, along came the C-130 out of service date. So, Air Mobility Force test squadron boss over here chooses Project
Tribune,
which is
really on my name. I don't know. You tell me.
Which is one better than Centurion. Rubbish, absolute rubbish. Yeah, so that happens, and we see that routinely. So even on the on the rotary wing side of it, we'll see that programmatic pressure. We're never immune to programmatic pressure. There's always a fixed date required for some sort of capability, driven by the big program changes or by an operation which comes out, and we are used to reacting to that. That's I think all the people within my organisation would reflect at some point. Okay, they've had to put the pedal down on the workload to get it done, and we're quite used to scaling for that across all the fronts.
Yeah, and I think our job is, we understand the imperative to get some of those new capabilities to the front line and how important that is. We also don't want to leave our frontline colleagues short or carrying a risk or a dodgy bit of kit that has been.
So what role do you play in supporting frontline?
So if you like, there's two real kind of areas we support directly. Okay, so there's the big programs that are running to a big drumbeat, to replace them. That's in the Air Force, and on the air capability side. They're the people who look at the capabilities. And then there's the frontline side, looking at more acute tactical problems. And so each of the squadrons, the test squadrons, will be facing off against those two areas to try and support the big programs that range to a big drumbeat, but also the more acute problems, tactical problems. So for example, when the Ukraine war kicked off last year, 41 Squadron to support the Typhoon Force that were rolling out of the door to do their enhanced NATO policing presence, there were some things that required out the rush. So therefore, we just put the pedal down and delivered some very short tactical gains that sat out with any big program to support that. Polar Bear recently?
Yeah, which was the recovery of civilians from Sudan.
Yeah.
We had done some A4M trial work that would have been really useful for the front line in landing in shortened runways that might be breaking up. So my team had done the trials work but not finished off the report. We worked through the weekend to get that report out to the commander air wing at Bryce Norton so they could understand the risk they were holding and allow their frontline to do that. And then we looked at all the other contingencies that might have affected that aircraft. So we looked at if you lost an engine in Sudan and needed to take the aircraft off with only 3 engines, we practiced that in the sim, so the front line had that ready in their back pocket if they needed it.
So that's the long answer. The short answer is it's either through a big program that's going to support them in 1, 2, 3, 4 years' time, or it's the direct acute. We'll give that advice right now. We just scale between that depending on what the pressure is at the time.
So and that's the similarity between you and the Rapid Capabilities Office, I presume, who appeared on Inside Air, one of the first episodes.
Okay, yeah.
And so going back to the war in Ukraine, has that initiated a drive to change, develop, or adjust different practices?
The best thing I can highlight out of that was when everything kicked off and there was that realization of, okay, we've been shaping for a particular conflict region, a sort of generic conflict region. This is now an acute one. We can see it right there, and therefore we need to know what immediate capable enhancements we need just to push us up a notch in terms of our lethality from a combat air perspective, in terms of sensor effectiveness from an ISTAR perspective. So each of the forces had I've got a shopping list, but there's a requirement set that they'll need. And my best example, I guess, would be on the Typhoon side, where there was a particular requirement to just tweak the software in one of the effectors, one of the missiles it's got, which came with a burden of other bits of the air system, the platform, which also needed to be tweaked in. Because we'd already done some pre-work on some of those things and had planned a firing much later in the year, we were able to bring them together, and within about 6 or 7 days, immediately gave some advice that, we think you could just take risk and go and do is load it right now, which is what they chose to do. Frontline commander, big thumbs up, and decided to take some operational risk, which is great to see. But we then said we can tell you the truth about that within a 3 or 4 day window, and we ran a rapid trial, brought everything forward from September through to March, whenever it was, to then go and prove what was behind that, and therefore take away any absence of any information, any ambiguity, so they knew that decision was the correct thing to do. It worked really, really, really well, and we've seen that play out in a couple of other areas as well. So it's been galvanising in other areas, which we won't touch on too much here, but it's certainly been a useful forcing function to have a think about, right, we've got a specific threat set now. How do we now rapidly tweak and rapidly test and therefore rapidly advise frontline commanders on what their systems can do?
So going back to my first big question about, do we need test pilots in a synthetic world? What would be the balance of your activities, synthetic trainers versus flying?
So I am going to pick you up, because you said a couple of times you keep talking about test pilots, and I always break it down to test professionals or test aircrew, because I include the FTE branch there. So almost 1-for-1 in terms of numbers. We match on any given program. You'll match a test pilot or an evaluator pilot, someone who's a bit more a tactician, with someone who's going to help manage the trial and do that blend of pure operator into the broadside. So to your question then, sorry.
No, that's fine.
Which is about the synthetic blend, which is fascinating. So there's two things. If I describe synthetics as being what I think our listeners would call a flight simulator, so certainly they recognise a box that you jump into, a representation of the world, a representation of the aircraft. If I use that as my definition, actually our job is first of all to make sure that represents the aircraft, and you can't do it the other way around. And it's actually really quite a large body of our work, is to make sure that the flight simulator looks and feels good enough, and it has to be good enough to the real aircraft. And if there are any differences there, and you'd be surprised at how many there are. It's quite tricky to represent complex aeroplanes well, either their flight model or their systems model. So advise on the differences, what they are, okay, and then advise whether you think they're really critical and there's any kind of like big howlers that might come back to bite you in 5 or 10 years' time. And again, those are out there. So quite a large job is not going in there to do tests, it's making sure we test the simulator to make sure it's the same as aircraft. So it's the reverse engineering.
Creating the data set that...
Quite so. Now, once done, can we use that to help hone frontline tactics and stuff like that? Yes, you can, provided you understand the differences. So there's a bit of a flow that way. Now, that's what I think your users would call a flight sim. Other synthetic models and simulations are available. So, for example, Typhoon has a weapon system rig, the Whizzer, which is a largely exploded airplane, if you like, and we can stimulate that largely live model with various things, which helps us tune and test the defensive aid system. Very useful way of doing that. So there are degrees of doing this. The modelling and simulation thing is not new. We've always done modelling. We've always stimulated those models somehow. It's just the models were made of balsa wood, and the stimulant was a wind tunnel. And that was never perfect, because if you know your aerodynamics, the Reynolds number will be wrong, and you had to do various things to the air to cool it down to make it appropriate. So we've always done it. What we're doing nowadays is increasingly taking it from a real model or a real stimulant to a synthetic model and a synthetic stimulant. But there's still a burden there. You can get often more accuracy out of it. But if you want to keep that model going for the lifetime of an aircraft, you have to invest in that model, albeit it's just on a floppy disk, for example. Show my age there. You have to keep that going for 40 years of the program. So we've always been doing it. So we're taking the synthetic thing and hoping to try and refine it. It's not cheap, it's not free, but what it does allow is it means you can hide it from our adversaries. So actually, the tension, if you like, and a big challenge we have at the moment is that increasingly, particularly for the high-end capabilities, we don't want to show our adversaries what we're doing in the live air. So we want to do that synthetically. But back to my first point, we have to prove that the model is correct and the stimulation of that model is correct. So how on earth do you square the circle? I don't have an answer. No one has an answer. It's a challenge we're trying to face.
Winding back the clock a few years, I remember being sat on a C-17 somewhere over Afghanistan with a massive truck right in front of my face, like nose up to this truck. And that is a little bit unnerving when you're on the back of the aircraft. Are you responsible for the people who do the test and make sure that that's safe?
So there's an organisation called JATU, the Joint Air Delivery Test Evaluation Unit, that sit within the Air and Space Warfare Centre umbrella. And they've got a series of responsibilities. One of the things you're talking about is how do you take a load, often an unusual load, and restrain it on an air system, an aircraft, and you can go online and find some pretty horrendous videos of what happens to an aircraft if you get that wrong. And the answer is, sadly, no one makes it out alive. So tying that down, as you said, to make it resistant to the in-flight loads and the crash loads as well is very important. So we've got a team within JAD2, this unit, who do that, and they're often deployed at short notice because you'll get some unusual things that need to go on aircraft, and the only people who can do that are these people. So a hard-working team. Two other teams that I'll just give a shout out to on that organisation are the air dispatch team. So AD spoke about the dispatch trials of various loads, talk about the maritime platforms that are in the boats, that the team who do that and design the system that then and the release mechanism, etc. The guys who do that are the dispatch teams. We frequently work, and AD's team will have those down the back of the A4, etc.
British Army, aren't they?
Oh yeah. So this is a joint unit as well. Yeah. So we're here as airmen, and this is an air podcast, but the Air and Space Warfare Centre, and in particular that unit, are joint inherit with purple unit throughout. So air dispatch team, and the other one worth mentioning is the parachute test team, who we talk about testing aircraft, crewed or uncrewed. These are the guys and girls who test parachutes, either new parachutes on all aircraft or old parachutes on new aircraft. So they've been heavily involved with the Tribune trial to replace the C-130 over the last year, and throwing yourself out of an aircraft, high altitude, say, on a parachute system that's never been testing as an aircraft before. That requires a certain degree of human being who does that. But the training. I'll give an example. The training we do for them is. For those listeners who aren't familiar, you always have a reserve parachute. So you jump out and your main parachute opens. If that goes wrong, you have a reserve, and you can cut away your main, it floats off, and you open your reserve. We make them do that. Twice a year we make them do that. So obviously daft to not give them a third parachute, so we give them a third parachute. So they jump out, they open their main, and they're floating down happy. And I think this does take a certain degree of it feels like a big leap of courage. You then cut away that perfectly serviceable main to then go on to your first reserve, knowing that you've got a second reserve if you need it. So that's the training we do with these people.
So here you both are doing these jobs, absolutely fascinating jobs, but it seems like you need to be pretty switched on upstairs. I don't know how you did at GCSE maths and physics and so on. What does it take to become an engineer in this world and to become aircrew in this world? Well,
you do your qualifications first. That way I won't be embarrassed.
Yeah, fair enough. Yeah, so I joined the Air Force, and I guess like the standard route, which I did aerospace engineering, and then I did a kind of like what I call the normal foundation tour as an engineer, as a Jenga on the mighty VC-10, and then I worked in DNS on the Tornado GR4, and then I went for selection to become a flight test engineer. I think here, scarily 13 years ago, and then I volunteered to go on exchange to France. I hadn't learned French, so I spent a year learning French, and then I went to France to learn aviation French, and then a year sort of totally immersed in the French military and aviation culture, which was, to be honest, an utter privilege. Flying a whole range of Airbus aircraft and fast jets like Alpha Jet, Mirage 2000, etc. over the Mediterranean. So I think I had good enough academic qualifications. That gets you probably past the course. I think what we really look for in our candidates now is that ability to kind of not be flustered, to be able to think on your feet, be able to unpick those problems, like, oh yeah, you want to clear, a new fast roping rope from a Puma helicopter, and we ask that question to a fast jet pilot or a multi-engine pilot, just to try and take out their comfort zone, and they work out some, they show some really sort of clever, detailed analysis, and that's what we're looking for, that kind of initial thought process that hopefully the test pilot schools then hone over a year-long course. So
there has to be the academic foundation to get where you are today, but there's a bit more to it.
Yeah, there's definitely a requirement to have some academic background and a technical background is very useful. Now, we don't exclude based on that. And for context, we're down at Boscombe Down with some other squadron commanders because we're now in the 2-week selection window for next year's ETPS course. So it's a once-a-year event.
The Empire Test Pilot.
Yeah. So, and we've been asking the sort of questions that would have challenged me 17 years ago, I think it was. We're definitely looking for that. I'd observe, and we asked the question, what we think the most important attribute is, and there's no right answer, but certainly from a test pilot perspective, there's an element of self-awareness, and I don't mean by self-awareness. Your listeners at home will recognise this. If you get a bit of a hire car and you drive your hire car, and there's just something that annoys you, human resilience means that most people will just get on with it. Okay, and most of our frontline crews are very, very resilient humans. So if they find a problem with something as simple as the switches, buttons, and menu structure of their aircraft, they're very good at flying around that, and they won't recognise that that's annoying them and that it's stopping them doing something else because they're very competent human beings. There's a bit of the test aircrew side of it that needs to go, oh, hang on, I just pressed the button twice. I need to stop now. Now, is that true? Did I just press it twice? Is that annoying me? There's something wrong there? And enough of those double button presses, or I can't quite see the display properly, or do I have to work really hard with this aircraft to make it do what it's supposed to do? And I could probably just work hard through it. That's fine. But you need that self-awareness to stop yourself. We call it compensation. Stop yourself compensating for it and go, why am I working really hard here? Recognise it, articulate it, describe it, and then relate it with a degree of empathy. So that's my second point, self-awareness and empathy, that there will be some junior pilot or junior aircrew somewhere within the system who will not be able to cope with that as well as you did. So being the best pilot is nothing to do with it. It's about being self-aware and then being able to empathise how that's going to affect someone when, in the dark, on goggles, when someone's shooting at them, they need to go and execute this perfectly, this well-rehearsed discipline drill, without having to press every button 7 times or turn up the display again because they can't see it. So I think that's kind of the challenge. You asked me 2 questions. One was what do we see for people in a technical background? Prior to that is how did I get here? So I came through a bit like Adi, I got just enough GCSEs, and I think I probably fewer than Adi, dare I say it, to get just enough A-levels, then get myself to university, and then I did a university degree in aeronautics, astronautics, joined the Air Force. And my hook was I was very lucky to get posted to an evaluation unit, and at that point I got bitten by this bug of fielding the new equipment to the front line. It was at the end of that chain, if you like, a specialist unit. And after that, I said, this is my calling. I can see a way of taking new equipment, which is never perfect. But the analogy I give the Christmas Day analogy, and Adi's laughing at this because he's heard it 1,000 times. So Christmas Day, you open your present, and it's some sort of technical present, something, some sort of machine that you've asked for, and the instruction manual is obviously translated from Chinese. It's not particularly clear, and you're not quite sure how it works perfectly. And by about the 27th, you've worked out that it's not as good as it could be. It's a bit disappointing. And by the 28th, you've kind of worked out actually how I could make it better. The 29th is covered in blue tack, and it's operating way better. By the 30th, you've rewritten the instruction manual into plain English that you can describe to your best mate about how to make it work. And by the 31st, you've emailed the manufacturer and said you really must make these changes. That's that Christmas Day effect of taking new equipment, new weapons, new software loads, or even old equipment putting onto new aircraft, or however the combination works out, and working through that feeling of, oh God, here we go again. I don't really know how it's supposed to work. It's definitely not going to work perfectly first time. What can I do to make it better? How can I give it the best all at the front line? And how can I tell the manufacturer, for goodness sake, for version 2, because there'll always be a version 2, change the following. That's how I got into it, and it is an exciting bug, and for that reason a lot of people come to it and are galvanised by the work that goes on.
So if someone is listening to this and there's all, that's me all over, and if aircrew, engineer, and they've already jumped through a lot of hoops to get where they are in their career, and now they're going to have to jump through this really big hoop, your selection process. Can you give away any state secrets of questions they're going to be asked? They might get one ahead of one up on a colleague.
Before I do that, I think it is the sort of thing we need the people who can do that empathising thing. So they need to understand what the role of their air system is, how it fits into the big military picture, or if they've got a broad background, how the breadth of that fits into the big picture. So coming, very fresh out of training and very enthusiastic is great. What we look at is, a bedrock of instinctive understanding about military air power and where the bits they're going to go into and the bits they've seen previously, where they fit into that big picture. So I guess that's my first appeal. We do like enthusiastic people, but there's got to be a bedrock of knowledge there. As to questions, AD, what do you think?
We do definitely want them to be the ambassador for their force, and almost sort of an ambassador for their mates on that front line. Their mate that's on that dark, windy, long night, doing something for the first time. I think we do want inquisitive minds, don't we? We pose some very detailed military questions. Again, often not on an aircraft that they are used to sort of stretch them a bit, and then we're interested in their broader kind of aviation knowledge. I mean, you challenge them with the standard question of how is AI or machine learning going to affect our world in the next 5-10 years, and we expect a very open answer, because I don't think we know where it's going to go. What we want is sort of flexible, agile minds that can exploit the most out of that. So hopefully it's not as daunting a process as it used to be.
Yeah.
It was certainly hard in our day, wasn't it?
Obviously.
And as the boss says, we chatted before, didn't we? There's the ETPS documentary on YouTube from the mid-80s. I was just about alive then, which was all about amazing pilots. I'm looking for pilots that can, as you say, can gather data, understand why they're doing things, and relate that across to like-minded pilots or aircrew on the front line.
There was a lovely line in that. A former Harrier test pilot talked about looking into the corners of the envelope. And is that still the case today?
Yes. So, back to your modelling and simulation thing, it's interesting when we, let's take an envelope, and it depends which metrics you're going to use, but a conventional aircraft handling envelope, you go for speed and height tends to be where you look at. So the stuff in the middle is quite straightforward. It's the edge case bit is where you might need to go and look. So rather than do 1,000 test points across the whole envelope, much better to try and model it, simulate it, let's say the core part of the envelope, and then go and test against that and make sure your model and sim's in the right place, and then go and model and sim at the extremities of the envelope and gradually approach those. So it's a way of reducing the burden associated with that. But yeah, certainly we'll usually start somewhere towards the safer edge. So the classic would be, dropping a new weapon off a platform. We do it very fast. That's where the higher kinetic speed is, higher energetics from the or higher dynamic environment is. We're very slow. The aircraft will be quite high nose attitude, so they'll come off at a funny angle of attack. So choose somewhere in the middle, and then work towards one edge or the other. So we do the core edge of the envelope stuff and the corner of the envelope stuff, but we tend to, as we go, validate that we've already known. And if the validation of the model starts to diverge, then we get worried. If it stays together, then you go, actually, I can now extrapolate that to where I need to go. So it's fundamentally nothing's changed. The tools that get us there, I think, have altered and got more impressive.
Yeah, and we last year were involved with the Voyager Sustainable Aviation Fuel Trial, which was one of my flight test engineers, Rolls-Royce and Airbus. So we're putting this fuel, which looks very much like Avtur, aviation fuel, but made in a different fashion rather than just extracting it from the ground. That was definitely going to all the corners of the envelope to really stress test that engine to prove that it didn't shut down or didn't have what's called surges where it kind of flames, and that new fuel we put into the aircraft, the engines behaved in the same fashion. So that was sort of classical flight test, really.
And even what day is it today? Tuesday. So yesterday, the Rotary Wing Test Squadron, based here at Boscombe Down, they embarked on one of the major ships, can't remember which one.
Argus, I think.
Argus, yeah, to clear the Merlin Mark IV, so the green Merlin, the one that carries the commandos around. They're expanding the envelope on that. And what does the envelope there mean? The envelope here is defined as where's the wind from. So obviously the wind comes over the superstructure. It can cause some turbulence. If it comes from Merlin, let's say port side, if it comes to the left of the helicopter, you can have tail rotor authority. If the ship, is get my terminology right, otherwise the Navy will tell me off. If the ship is in particularly bad sea conditions, if it's pitching, or if it's rolling from side to side, or corkscrewing, that can make the pure piloting task of trying to put your helicopter on the deck really hard, and that's when you get into problems such as over torquing the engines. So that is probably niche stuff, and they will be on Argus. I think it's 3 weeks, and again back to the teamwork thing. Dear Captain of the Argus, take us to somewhere where, let's start with this very benign little envelope. Okay, now we need to go and find some big winds from the port side. Okay, where on your weather map of the North Atlantic, wherever they are, does that exist? Take us there and we go and do it. Okay, we now need some rolling seas. So it is, and they are properly not just operating to the edge of the envelope, they're making the envelope bigger and bigger and bigger and bigger, so that the Frontline know when they come back to a ship in 30 knots crosswind, whether they can land there or not, or whether the captain of that ship has to turn left a bit, right a bit, and give them a bit more headwind. So and that is fundamentally unchanged from a long time ago, to be honest.
Mm-hmm. Okay. So we talked about the golden age of test and evaluation. How would you describe the current age, and where are we going? What comes next?
Yeah, I mean, I've chatted to my people about this quite a bit, actually. I graduated from uni in the early 2000s. It was quite an exciting time. There was A380 on the drawing boards, A4M was on the drawing board, but they were quite classical, standard aircraft, standard engines, standard fuselages. I really do think in the last 5 years that sort of the speed of aviation technology, civilian and military, and crossover is absolutely rapid. So I've got bods that are involved with the classical flight test program, so my people. But with the tutor replacement, for example, I've got people trying to understand how batteries work on aircraft, how hydrogen fuel cells can be a future fuel source, either for aircraft or maybe just for generation on the ground for a deployed base. I've got people trying to get a rapid SATCOM availability onto A4M by using literally things that are suction mounted onto the windows and understanding that tech from first principles. So I think if you're an engineer now and a graduate, you're walking into an exciting, rapidly changing environment, and I think we are generally also trying to embrace some of that speed of change and the great capabilities that come with it.
Yeah, so I'd observe that's a good pitch actually. I'd observe two things: that the Royal Air Force in particular, I think it is light blue in particular, have a very, very large, if you've got a capital refresh of their air fleet. So look at the things that are coming on. So P8's just bought itself, E7 Protector is just around the corner, A400, F-35's out there, Typhoon's going through a bit of... There is lots of new stuff, all the big programs. Now, and that's good, that's a large body of work for us to deliver. But what typically happens after that is you go into the refine phase, where you go, I've got it delivered, and I need to refine it and make it as good as it possibly can be. And often in those phases is where you see the adaptation. It's not really innovation, it's adaptation of what you've got, and that's where I see a lot of exciting things. Aidy's just spoken to about things like putting ADSB. It's a very straighthtforward system. Let's just put it on
unmanned aerial systems.
Well, that's my second point. Sorry. So on the crew level, I think it's quite an exciting time because we'll be into the refine phase, and this is often where you take where you take a big blunt object, is a bad word, but then you really hone it, you really put the cutting edge on. So I think that's quite an exciting time to be in both the tail end of the capital refresh phase, but also how to hone it. That's point one. Point two, and this is contemporary, is the unmanned side of it. So yes, we've got Protector coming along, which is the replacement for the Reaper. So a big certified, it's as big as an aircraft, as big as a big light aircraft, big certified thing. We're hoping to maybe fly by the end of this year. in the UK, and that's going to be a big, long, enduring project. But the smaller side, we've seen Ukraine, and if I call it the explosion of if I call it the brigade level unmanned, so something that in an army unit's brigade, that's something they'd be used to, but probably for us, something that's about this big, and I know it's radio, but I'm holding my hands, something about 3 or 4 meter wingspan, something that weighs about 25, 30 kilos, that can go about 20, 30k. There's just this explosion of that, and some of that, well, a lot of that is commercial technology. Caution, some of those are little better than toys, so they will fall out of the sky. They will have, they'll be easy to take down electromagnetically, and some of those are a bit more resilient. So that whole explosion of that, we recognise the Aerospace Warfare Centre, that if we want the frontline, and now I'm talking about the Army and the Royal Navy and the Air Force frontline, if we want them to have equipment that's good enough, but is also resilient in a war-fighting environment, and it isn't just a toy that someone's taking to the field. It's actually going to survive contact against the enemy in the war, because they will try to get something against that. If you want to do that, we need to get after that. So only 7 months ago, here at Boscombe, on one of the test squadrons here, a ground-based test squadron, we've established the tactical unmanned test and evaluation flight to go and look at that exact problem set. How do we get after that? How do we let the front line know that what they've got is effective, is definitely going to survive in a war, it's definitely going to help you contribute to a warfighting effort, also isn't going to go so rogue that it's going to be unsafe. So I mean, and there's an explosion in that we're trying to get after, and that's definitely a change I've seen since I started this job 2 years ago. To answer your question. Yeah,
it does. I mean, what I'm hearing today is understanding that test and evaluation isn't just about the test pilot, it's the relationship between the pilot, the aircrew, the engineers, all the support that goes around that, and people are at the very heart of what you do.
Yeah, exactly that. And I'll use the word empathy twice. I'll use this the second time now. So within that big broad team, there's a broad team. Everyone within that, from industry on the left to the frontline users on the right, is going to have a different view of whatever you're doing, and being able to recognise that each of them comes to that with something to bring, something to get out of it, and being able to sew that together in a coherent team. That to me remains the beauty of the environment that me and my team are working within, and the great enjoyment, but also, honestly, sometimes the great challenge of it as well.
Yeah. And I guess for every person serving in the Royal Air Force that has ever flown in the cockpit or in the back of a transport aircraft, they're there because of you or your predecessors have tested it and made sure it works safe, reliable. That's the job.
Safe, effective, and then hopefully helps to refine it as well. It's a big job. Really?
Yeah, and I think going on from that sense of job satisfaction, when I was a junior engineer officer or a senior engineer officer, I was really proud of my team and my people and how they got aircraft serviceable. But you were just one sort of part of one small part of a very good but big team. Here my people are you're responsible, pilot, loadmaster, flight test engineer, for managing this trial to clear high altitude parachuting, and they get loads of responsibility and a real sense of, I can really see what I achieved and what the Air Force is trying to do in the next 6 months, year, 5 years.
It's a very broad view. I'll just highlight one thing, and I will mention this. So I was out recently to witness a trial. I wasn't participating in it, and it was a trial that involved Typhoon, F-35, and another two systems against a variety of ground systems, and I went to the sort of central control room, if you like, where there's a sort of fairly junior squadron leader, trials officer from the air platform protection. So, if you like, the electronic warfare and defensive aid test and evaluation squadron, who was sat at the centre of probably 10 radio nets, talking to the ground stations, talking to the 4 different flying systems, talking to range control to make sure airspace, the controlled airspace was contained, if you like, and And it was amazing to watch the degree of trust we put in some very junior people to do that. And again, back to that entire thing, it's been controlled and orchestrated by someone who we just delegated, right, go and run that trial for us. Put together a lot of very expensive assets up on that day, all working together. The closest analogy I can give is the Apollo control room. That kind of feeling of little mini teams all communicating with one central director to try and bring the whole thing together. And it's quite a joy to watch when that happens, and watch something which is actually could be fiendishly complicated. Oh, by the way, it never goes perfectly first time, right? So there's always some sort of fallout or some sort of problem to be dealt with. But watching that being managed actively and coherently is actually it's really, really quite impressive. And then the line up to get there would have taken years. The debrief would have taken days to try and nut through how they manage the problems. The data reduction and how we work out the effectiveness and the systems we're there to test will take probably a good solid 6 months to get through that. So an amazing event, and I think a very, very good demo of that teamwork thing and where you sit within that team.
Super. Well, Group Captain Berry, Wing Commander Wolven, thank you for sharing your insights into test and evaluation. Thank you for being on Inside Air.
Peter, my pleasure.
Yeah, thanks so much. Thanks, Peter.
Really enjoyed it.
This is Reheat for Inside Air. I'm AS1 Victoria Andrews. 2 Typhoon squadrons have deployed simultaneously to Operation Carson in Poland and Exercise Bersama Lima in Malaysia. In Poland, pilots are undertaking combat air training with NATO allies Poland, Italy and Spain. This training includes dogfighting against different types of aircraft and close air support training that helps ground forces in combat. While in Malaysia, the Typhoons flew nearly 7,000 miles with support of the Voyager aircraft to work together in an air defence scenario with partners from Malaysia, Singapore, Australia and New Zealand. These nations form the Five Powers Defence Arrangement, which is a defensive military agreement to help maintain security in the region. RAF aviators are participating in NATO Air Force's annual counter-chemical, biological, radiological and nuclear training event, Exercise Toxic Trip 23. 18 national air forces and Australian, Swedish and South Korean allies are training together to rehearse and integrate their counter-CBRN defence procedures with a realistic deployed airbase scenario in Belgium. Flight Lieutenant Chris Bond, RAF Regiment, who deployed at the start of the Salisbury emergency and is the RAF Detachment Commander, said, "This level of realistic multinational training shows just how serious we are in preparing against our adversaries who may be willing to use CBRN weapons." UK Lightning stealth fighter jets have launched from HMS Queen Elizabeth to join Royal Norwegian Air Force F-35A Lightnings, escorting a Russian maritime patrol aircraft as it flew in proximity to the UK carrier strike group. RAF Marham-based 617 Squadron is currently embarked on the UK flagship, which is conducting an autumn deployment with simulated missions in the North and Norwegian seas. Following participation in Exercise Cobra Warrior, the UK Carrier Strike Group is working alongside ships and personnel from Joint Expeditionary Force nations to demonstrate their ability to conduct air operations into Norway, Sweden and Finland. And 99 Squadron have undertaken a free-fall training exercise, which has allowed the Royal Air Force's Frontline C-17 Squadron to maintain vital parachuting currencies. Exercise Paramoose also allowed members of the Airborne Delivery Wing, the UK's military parachute training school, to complete their own dispatcher and drop zone safety officer qualifications. That's Reheat on Inside Air.
Thanks, Vic. And now it's time to find out who's under the hat this time with Ben.
I'm AS1 Ben Russell, and this is Under the Hat, where we get to know an aviator in less than a minute. Name you're known by.
Sergeant Tommy Godfrey, Goddard.
What's your profession?
Physical training instructor, ex-Royal Navy and currently serving in the Royal Air Force.
What's the best thing about your job?
It's helping other people understand their capabilities by encouraging them on physical lessons and seeing them getting fitter, stronger and more confident while performing functional movements.
Hardest part of your job?
Well, I'm 44 now. I can still keep up with the mid-20-year-olds, but it certainly is getting harder and certainly taking longer with recovery.
Best location you've served?
I would say Dubai, Bahrain, they was always fun, especially after 6 weeks at sea in Defence Watches.
What bit of luxury kit do you never deploy without?
I'm sorry to say, it would have to be my mobile phone, keeping in contact with my wife and kids with pictures.
And what's your proudest moment?
Awarded the Commander-in-Chief's Fleet's Commendation, where I rescued 3 German sailors in the Baltic Sea while serving aboard HMS Cumberland. If you're ever RAF Halton around the Burnett, Jim, please pop in and I'll spin you the dit sometime.
Thank you, Sergeant Godfrey. I'll do that. Start of level 9. Actually, I might wait until next year, but thank you for being the latest aviator to take part in Under the Hat.
Cheers, Ben, and that's all for this episode of Inside Air. Please give us a review, it really does help us stand out from the crowd. Subscribe on your favourite podcast app and join us again soon.
You've been listening to Inside Air, a behind-the-wire view of the Royal Air Force, its people, technology and operations. If you're serving in the RAF and have a story for us, please speak to your unit media and communications officer. Inside Air is written and produced for the Royal Air Force by RAF Media Reserves.